what we were looking at before in the previous session. We did 2 examples which were involving addition. Today we continue with examples where we have subtraction. So our example 3 is x minus y to power 5. So we say the first thing is to come up with the coefficient, which we say you can easily get them from the mathematical table. Our 6th edition mathematical table, page 27, you can be able to get those coefficients. So just go to page 27, 6th edition. Now the coefficients of power 5 are 1, 5, 10, 10, 5, 1. Then we expand our terms, which are x and y. Now we say the first term we start with the highest power, x to power 5, x to power 4, x to power 3, x power 2, x power 0. The second one now, which has a negative, you must carry that negative. It is to power 0. You start with the lowest power, which is 0, negative y power 1, negative y power 2, negative y power 3, negative y to power 4. Now, if we multiply this, we say, recall that any number to power 0 gives us 1. So this one will give us 1 times x power 5 times 1, which is x to power 5. This one, the second one, will give us 5 times x to power 4. Then we have a negative times negative y, which will give us, we put a negative there, negative 5 x to power 4 y. We go to the third one, we have 10 times x cubed times negative y squared. If we multiply negative y squared, means negative y times negative y, which will be a positive y. So in this case, if we multiply all of them, we will get a plus 10 x cubed y squared. From there, we go to the other one, the other term. We have 10 times x squared times negative y cubed, which means negative y times negative y times negative y, which gives us negative y cubed. So we will have negative 10x squared y cubed. The last one, let me correct here. We have 1, 5, 10, 10, 5, 1. So this is x power 1, negative y power 4. The last one, x power 0, negative y power 5. So the other one is going to be 5 times x times negative y to power 4, which means negative y times negative y times negative y times negative y gives us y to power 4 positive. So it's going to be 5 plus 5 x y to power 4. And lastly, the last one will be 1 times 1 y to power 5, which will give us negative y to power 5. And so our answer is going to be x to power 5 minus 5x to power 4 y minus plus 10x cubed y squared minus 10x squared y cubed plus 5xy to power 4 minus y to power 5. Now, if you look at our answer, there is a pattern that is being formed where the first term has a positive, the second one has a negative, positive, negative, positive, negative. So it forms a pattern where the first term is positive, goes to negative, positive, negative, where we have a subtraction. That is our example 3. Now from there, we can still go to example 4. Our question is still use binomial expansion to expand 2x minus 3 power 4. And you can still get other powers like power 5, In fact, our mathematical table goes up to power 20, so you can still get all that. So the coefficients of 4 are 1, 4, 6, 4, 1. We start with the first term is 2x power 4, 2x power 3, 2x power 2, 2x power 1, 2x power 0. The bracket there is very, very important to avoid making mistakes when you are multiplying the power. So we have negative 3 power 0, negative 3 power 1, negative 3 power 2, negative 3 power 3, negative 3 power 4. If we multiply all this, we will get the first one is 16, x to power 4, because 2 to power 4 is 16, then x to power 4 is 4, negative 3 to power 0 is 1. The second one, so we have said it forms a pattern of positive, negative, is going to be 4 times 8 times negative 3, which will give us 4 times 8 times 3, this is negative 12 times 8, which gives us 96x cubed. The third one will give us 6 times 2 to power 2, 4 times 9, which is 24 times 9. This one gives us positive 216x squared. From there we have 4 times 2 times negative 27. This one again gives us negative 216x. The last one gives us, because we have said a pattern of positive, negative, gives us 81. So our answer is going to be 16x to power 4 minus 96x cubed plus 216x squared minus 216x plus 81. That is how we get our answer. So that is example 4. Now, what can we say about binomial expansion? When we are expanding using binomial expansion, there are things that you should look at very carefully. One, you must be able to read the coefficients from the mathematical table, and you read them well to avoid making mistakes. Two, it is very, very important to include the bracket when you are multiplying, and also multiply well to avoid making a mistake in the last part. Now, in our next lesson, we are going to look at the application of binomial expansion, where now we are going to look at application of what we have been looking in the previous 3 lessons, and we are going to move on well. Bye bye, have a good day.